Dear students, Assalamu alaikum. Now today's topic is graph of y equal to modulus of f of x. Graph of y equal to modulus of f of x, where f of x is linear. Where f of x is linear. How we can draw the graph of modulus function? Suppose we are having function here y is equal to modulus of x. How we can draw the graph of the modulus function? For this, first we have to draw graph of y equal to x, and you know graph of y equal to x will be like this. Graph of y is equal to x is this one. This is the graph of y equal to x, this straight line. Then you can reflect in the x-axis the part of the line that is below the x-axis. How you can reflect? This portion above the x-axis will be as it is. Below the x-axis, we will reflect this one, upper side, like this. Now in this red color, this is the graph of y is equal to modulus of f of x. In this way, we have to draw the graph of modulus of f of x. If here graph is y is equal to modulus of x plus 1, any constant is adding here with this modulus. Graph of y is equal to modulus of x plus 1. Then how we can draw the graph? This graph will be like this one. Is, you know, graph of y is equal to modulus of x is like this. This one. Okay. This is plus 1. Plus 1 is outside the modulus. Then what we will do? We will take as this on the y-axis, at y is equal to 1. Then we'll consider this one, y is equal to 1, the new x-axis, translated x-axis. We will consider this one, the new x-axis. Okay. Then as y is equal to modulus of x is like this, then y is equal to modulus of x plus 1 will be like this. This one. Same graph will be there as of y is equal to modulus of x, but it will be along new x-axis y is equal to 1. This new translated x-axis. Okay, this is the actual x-axis, this x prime, you can say this is the new x-axis. How we can draw this new x-axis? If this 1 is outside, then you have to write here 1. If 2 as it is, then we will go up to 2. If this is y is equal to minus 1 or minus 2, y is equal to modulus of x, suppose minus 1 is here, then how we can draw? Is graph of y is equal to modulus of x is this one. As here is minus 1, then on y-axis we will go down 1, mean minus 1 here. Here is the new x-axis, okay, translated x-axis. Then at this point, we will take the turning point here on the y-axis, and this will be the graph of y is equal to modulus of x minus 1. If minus 1, we will go down, minus 2 more down, minus 3 more down, like this. And for positive, we will go up. This is the way to draw the graph of modulus functions. Or one more thing I can tell you here. In these type of functions, we can draw graph of y is equal to x plus 1. Okay, we will remove this modulus. First, we have to draw the graph of y is equal to x plus 1. That graph will be like this. Okay, then below this new translated axis, okay, below this one, the portion that we will take the image of that one. Okay, then in this way. Okay, as here y is equal to only x minus 1, not modulus. Okay, without modulus, only x minus 1 if we are taking, then graph of x minus 1 is this line, this one. Okay, then this new x-axis mean the translated, below this we will not draw, and we have to take the image of that one upper side. Okay, at the positive y-axis, positive side the y-axis. Okay, this is the way to draw the graph of modulus functions. Now we are going to start the exercise. Exercise 1.5. Question number 1. Question number 1 is having 6 parts. I will do first and the last part. First part, part A here is y equal to modulus of x plus 1. Y is equal to modulus of x plus 1. First of all, we have to draw the graph of y is equal to x plus 1 without modulus. For that, I am preparing here one table. Just a minute. Yeah, this one. Oh. First, we have to write here x. Okay, as x is independent variable, we can write from our side 0, 1, 2, 3, 4. Then we have to substitute here value, and we'll get value of y. In this equation, we will substitute. Okay, first of all, we have to draw the graph of y is equal to only x plus 1 without modulus. Okay, then x 0, 0 plus 1 will be 1, y will be 1. Here x is 1, 1 plus 1, 2, y will be 2. This 2 we will put here at the place of x, 2 plus 1 is 3. Then y will be equal to 3. Here at the place of x, we will substitute 3. Then y is equal to 3 plus 1 is 4. Then this 4 here we have to substitute. Then 4 plus 1 is 5. Y is equal to 5. Okay, in this way, we can get value of x and y different points. Now we are going to draw the graph. This is y-axis. This is x-axis. And this one is y-axis. This origin 0, long x-axis 1, 2, 3, 4, 5. Long y-axis 1, 2, 3, 4, 5, like this. When x is 0, y is 1. X is 0, y is 1, this point. X is 1, y is 2. X1, y, long y axis 2. x2 y is 3, then x3 y is 4, x4 y is 5, like this. Then we have to join these points. These points. Okay. Below the x-axis, I'm drawing here the dotted line, white dotted line, as this is the graph of y is equal to only x plus 1. When we have to draw the graph of modulus of x plus 1, then the portion below the x-axis, portion of this line below the x-axis, we have to draw the image of that line. Okay, and that image will be like this, just the mirror image along x-axis. Okay, x we will consider the mirror. Okay, this is not accurate. This will be like this. Okay, this line is not straight, but you can use the ruler to make it straight. This is the straight line. Okay, this is the graph. Now we are going to do last part. Part F. Part F here is y equal to 6 minus 1 by 3x. Y is equal to modulus of 6 minus 1 divided by 3x. Now, first of all, in the same way as in the previous question we have done, here we will draw the table. Xy 0, 1, 2, 3, 4, 5, up to 5 enough. Okay, to draw any straight line, we need at least 2 points. Okay, with 1 point we cannot draw any straight line, because from 1 point infinite straight line can pass through 1 point. Okay, from 2 point only 1 line can pass, but if we will take more than 1 point here, more than 2 points, then line will be more accurate. Okay, here x, here is y. First of all, we are writing here x0, then 1, 2, 3, 4, 5. If we are substituting here x0, then what will be y? X0, this implies that y will be equal to 6 minus, first of all, we will take without modulus. Okay, 6 minus 1 by 3 into x is 0. This 0 into anything will be 0. It means this is only 6. Here will be 6. When x equal to 1, this implies that y will be equal to 6 minus 1 by 3 into x is 1. Then here we have to take the LCM. 6 3s are 18 minus 1, 17 divided by 3. Okay, 17 divided by 3. 5 3s are 15 and 5.6. Then x equal to 2 we are taking. Then it will be y is equal to 6 minus 1 by 3 into x. X is 2. Then this is 2 by 3. This will be equal to 6 3s are 18. 18 minus 2, 16 divided by 3. That is 5.3. Then x equal to 3. Then for x equal to 4, x equal to 5. All these values we can take here. If we are taking x equal to 3, this implies that y will be 6 minus 1 by 3 into 3, and 3 cancel with 3, or 6 minus 1 is 5. here is 5. Then if x equal to 4, then y will be equal to 6 minus 1 by 3 into 4, then 6 3s are 18, 18 minus 4, 14 divided by 3, 14 by 4 3s are 12, and 2 14, it will be 4.6. Then x equal to 5, this implies that y will be equal to 6 minus 1 by 3 into x is 5. That will be 6 3 is 18 minus 5 is 13 divided by 3, that is coming 4.3. For x equal to 5, that is 4.3. Okay, and x equal to 4, that is 4.6. X equal to 3, that is 5. This one is 5 here, and here is 5.3. This one here is 5.3, and this is 5. Now it's correct. Now we can draw here the graph. This is x-axis, and this is y-axis. Okay, you have to draw the straight lines. Okay, x-y plane, straight line, both axes. Now when x is 0, y is 6, x0, y 6, we can take here y 1 2 3 4 5, we can make it up to here like this. This is y-axis, this 5, and 1 2 3 4 5 and 6. Okay, it means x is 0, y 6. X is 1, long x-axis also I can mention here 1 2 3 4 5. Then x1, y is 5.6. This is 5, 5.6 will be here. Then x2, y is 5.3. 5.3 will be little bit more than 5. Then x4 is y. X3 is y5. 5 is here. Then at 4, 4.6. 4.6 here. At 5, 4.3. 4.3 here. Then this straight line is like this, but it will not be up to here. Okay, we can extend this one. For this extension here, I can show you. First of all, we will extend this axis, x-axis. Okay, how we can extend the x-axis? This is x-axis. Now this straight line will come like this, but below the line here, these I am drawing the dotted line. If you are drawing the dotted line, then after that you have to draw the image at the positive y axis. Okay, you have to draw the image as well of this line, this one. Okay, this is the modulus of that function, graph of the modulus of that function. Okay, as here, this is the turning point on x-axis. You know, on x-axis y will be 0. Okay, we can check here what is the value of x at this place, at this point. What is the value of x? That here I can show you. If y0 0 is equal to 6 minus 1 by 3x, then minus 1 by 3x other side is plus 1 by 3x is equal to 6, and x equal to this 6 3s are 18. Mean this value here is 18. Okay, at x equal to 18, this is crossing. Okay, the x-axis. This is crossing the x-axis. Okay, this graph is not much accurate. Okay, now this graph I will show you on the Graphmatica. Okay, then that will be clear for you. First one was y is equal to modulus of x plus 1. Y is equal to modulus of x plus 1. Its graph is this one. Okay, this graph and this graph, you can see this graph and this graph. Okay, both are similar. This one, this one. Now the other one is y is equal to modulus of 6 minus 1 by 3x. 6 minus 1 by 3x are x divided by 3. X divided by 3. Its graph is this one, as that is intersecting at 18. Okay, then I can make it more closer. Okay, you can see here this is before 20. Okay, at 18 this is intersecting the x-axis. This is the turning point. X is equal to 18. This is the turning point. Okay, now you can see this graph and this graph, both are similar. This graph and this graph, you can see both are similar.